Yeah. Is this what you want me to use?
Yeah, that's
okay.
fine. Yeah, that's, I have like all the answers up.
So the first thing you want to do is find your equivalent charge. So the first thing I have to do is add these in parallel, which basically you just add those straight across. So C equals 2 plus 3 plus 5. That equals 10. And then for the second one, the second one, just add those across. 5, 10, 15. And then, since these are, they're condensed, you can picture that in your head. So now you just have like, forget that's there, and that's there. So it's just do, boop, do, boop. Okay. And so then those are in series, so now they add this way. So 1 over C.
Oh, you can actually see everything for once.
Can we?
Yeah.
Nice.
There's not a light directly over it.
Yeah.
Equals?
It's 6.
It's 6.
C total equals 6.
Alright, and that.
C tot.
Alright, so then the next thing you want to do is use this equation to get the total charge in the entire system. So Q equals volts multiplied by
It's
C
15.
total.
It's not 150.
Oh, it's 10. Why is it 10 volts multiplied by 6 farads. That equals 60 coulombs. And then so now.
So that was the answer to the first one.
So
that was the first question. Because that was the total charge coming out of the battery.
Is that the same picture he used?
Yeah, it's the same picture with different values.
Okay. That was on the test?
This was on the test with different values. Well, both.
No,
So he's using the same skeleton key as last time, so all of the questions will look very similar, most likely. He might draw a different diagram, so just know what parallel looks like and what series looks like.
Okay. So now we want to find the voltage. Is that what that's one? The voltage?
Yeah,
across
the voltage across C1.
C1. So
Use the total.
you want to use the total
equivalent of C1, 2, 3.
So that would be 10. So the total charge in the system divided by the capacitance of 1, 2, 3, which equals 10. That equals 6.
Did you pass around in attendance?
I can make one really fast. And what's the last question?
No, there's no more. I'll go ahead.
Just keep going.
Okay, so yeah, good. Okay, so that's the second question. So when you're finding voltage of a specific capacitor, use the equivalent of all the capacitors in parallel because the voltage will be the same across all of them, and it's the equivalent capacitance of those ones in parallel that you'll need to use to find the voltage. So the Q total divided by C of the parallel system, just the parallel. So if you're trying to find voltage across C2, you do 60 divided by 15 because that was the parallel equivalent. Okay?
Does that only work for parallel though?
Yeah. So if it's just one, then you just use the. So if you had like a capacitor right here,
There,
you just use whatever value of.
So that was
Yeah.
the voltage across C.
That was the voltage across C1. Yeah, we found it. So the voltage across C1, whatever C1, and then whatever these two, whatever numbers we gave those would all be 6. So voltage across this one, and this one are all 6. They share the same amount of voltage.
Is that also true for resistors or just capacitors?
Same for resistors,
Same
yes.
for resistors.
Yeah, anything in parallel will share the same amount of voltage.
But in series, they all.
So in series, series is kind of like a voltage splitter. It takes voltage as it goes. But so like all of these together will take 6 volts. So if you wanted to find, the voltage here after them, it'd just be 10 minus 6. So yeah, these would be 4. You can find that in 2 different ways. So and then the last one was the energy stored in capacitor C2. So to do that, let's see. C2. So to do that, you're gonna first find the voltage. You want to find the voltage across this capacitor. So You do the same thing as you did here, except so. V for C2 equals the Q total divided by C45, which is just 60 divided by 15, which equals 4. Or you could have done the other way where you just said these had 6, so these must have 4.
What was that finding?
The voltage across C2 and whatever C. Yeah, so now we're gonna have, so to find the energy we now use the 1/2 CV squared equation. So we can do E equals 1/2 C, which is 5 times 4 volts squared. So 16 by 2 is 8 times 5 is 40. So the energy stored in C2 is 40 joules.
Do we neglect the 10 farads on the other side?
No, because it's only in this one. So the voltage will be the same across the two, but
you just do
but we're only finding the energy across one capacitor, so we only use this one.
Okay.
Yeah, if we were trying to find the energy across both of them, we'd use 15.
Okay.
Yeah, good question. And that was all of them for capacitors. I think that was the most tricky. Those are the most tricky ones. I think resistors are easier. Does everybody agree with that? Yeah. Okay. Should we just use the same video for the other problems?
Yeah.
Okay.
Just go ahead.
Okay. Start this way. Okay. So now.
Yeah.
Yeah. So now for the resistors. So the next 3 questions it says. Yeah, sure.
The energy used to find yours for the capacitor too.
Yeah.
Why wouldn't he use both of them in parallel?
So if he's asking just for energy across C2, you have to use the capacitance just across C2. They share the voltage, but their capacitances are different.
Okay.
So they'll have different energy across each of them. Yeah. Okay. And then so 4 through 6 have basically the same things, except the same numbers, except the capacitors now are resistors. So same shape. He did this on the test. So and the first question is the total current out of the battery is what? So obviously we have to find equivalent resistance to do this. So the rules are flipped from capacitance and resistance. So in series, the resistors will add, and in parallel they'll be inverted. So to find R, and so we'll just say this is R1, and then 3, R4, R5. So R1, 2, 3, 1 over R1, 2, 3 will be 1 over 2 plus 1 over 3 plus 1 over 5. I haven't done the math on this yet, so bad chance. What? 0.96. 0.96. That was quick. So R1, 2, 3. I'm going to go 0.97. Yeah, round out because it's a 0.967. So 0.97 ohms. That's fine to use. And then R45 will be 1 over R45 equals 1 over 5 plus 1 over 10. So R45 equals
3.33.
what did you say?
3.3.
3.33? 3.33 ohms. Awesome, yeah. So we have 0.97 ohms and then 3.33, and so now you can kind of think of these as condensed. So this whole system, like she said before, will basically just look like this. You can picture it as looking like this, with this being R1, 2, 3, and this being R4, 5. The same thing kind of works with capacitors, so you could think of these as capacitors on the other problem. And so now these are in series, so our total will just equal 0.97 plus 3.33. 4.3, exactly.
0.333.
Yeah, good enough, 4.3. So our total is 4.3 ohms. Okay, so now to find the current coming out, you will just use the V equals IR. So if we have V equals 10 volts equals I, and then R equals 4.3 ohms, we'll just do I equals obviously 10 divided by 4.3, so 10 divided by 4.3 equals 2.32 amperes. So there was the answer to number 4. So everybody understand how to get equivalent resistance and find current? Okay.
No, I was gonna just say, I mean, I guess there's that rule for, I guess remember that with resistors in parallel, the voltage splits, but in series.
What?
Or in series, voltage drops across, with parallel, it all is.
Says this, yeah, it's, I already remember that.
I feel like if you remember that, it's kind of easier to do the problems.
It's just saying voltage is the same across this one, and this one.
So, yeah.
Yeah, so that's important for the next problem, which is the voltage across resistor 1 itself. So voltage across resistor 1 only is the same as the voltage across resistor 2 and resistor 3. All three of them will share the same voltage. Okay, so to find the voltage across R1, all you have to do is do the V of R1, 2, 3 equals the I total times the equivalent resistance of R1, 2, 3. So your voltage for R1, 2, 3 is going to equal your I total, which is 2.32. About that. And times R1, 2, 3, which is 0.97. And you get something which is close to 2.25. 2.25 volts. So R1, R2, and R3 will all have 2.2 volts going through them. And you could do the same thing for 4 and 5. For R4, 5, you just multiply 2.32 times 3.33. So just do that. I'm going to do it. And that should equal basically the inverse of this to equal 10, which would be something close to 7, well it says 7.73, but it would equal 7.75. It should equal really close to 10, it should round somewhere close evenly. So V45.
Is that annoying?
Oh, but it's better than chalk. So yeah, V45 would be 7.75. I'll make it even.
Are you talking about current?
No, talking about voltage.
Oh, not yet. Okay, never mind. I guess it's
Okay,
applies
so
to the next one.
okay, that's 5. Okay, so the last question is the power dissipated in heat is heat in resistor 2, and technically this was supposed to be resistor 2, so we'll say R4 in this case. So the heat, the power dispersed as heat is just the power equation, which is P equals I squared R.
Do you already have that pre-answered?
No, I don't. And so we have to find I in this case because I splits between 4 and 5. So current splits, voltage does not split. Okay, so so we can find, so if we know the voltage across 4 and 5, so the voltage across 4 and 5 is 7.75. And the resistance is 5 for R4, then we can find the current going through it. So V of 4.5 divided by R of 4 equals the current going through 4. Okay? It's basically saying the voltage of 4 divided by R4 equals I4. So
remember that in parallel, the current splits between the branches, and in series, the current is the same across each resistor in series.
Mhm.
And that should help.
And then R4 is 5. And so 7.75. 1.55. Equals 1.55 amps. Okay, so now we have the resistance and the current going through R4. So now the power of 4 will just be P equals I squared, which is 1.55 squared, times R, which is 5.
We only have to do that for resistors to find the current through.
You'd have to do the same thing for the capacitors, but that's not something you're usually interested in. It's just, yeah, only in resistors are you usually interested in the current on one of them. Yeah, you're usually interested in the charge across one in capacitors.
Was this the
Because,
unit where
yeah.
they had like the T approaches 0, approaches infinity?
Yeah,
like
this is,
problem?
yeah, that's the next problem. So I don't know what that answer. Did anybody get a number for that? 12 exactly?
Yeah.
Wow, that's awesome. So 12, I think it's watts. Yeah, powers in watts. So power dissipated as heat is 12 watts. As far as I can remember, it's watts. So, are there any questions on 4 through 6? Yep, it's watts. Awesome. Anybody? All good? Okay, so now I'm gonna erase all the rest of it.
What was the test average for Q?
Does anybody know what the test average for 2 was?
That was like a 60 something, wasn't it?
It was something below 7, so he's obviously giving you another chance. So, does everybody have all this down that they want? Okay. So the last problem says there's 4 resistors and 2 capacitors. I do believe. Okay. So a battery is connected to 4 resistors and 2 capacitors as shown. So we need a battery, 4 resistors, and 2 capacitors. So who wants, I don't know what exactly I want to do for this. What did he do? We'll see what he did, and that will help us. Okay, we'll do that then. So he did something that looked like.
What's the bottom of that beam thing? His 2 extra credit problems are from test 5. Is that what it said?
Yeah, it's that really
So
long
study
problem.
5.
It's a really long problem.
It's a really long problem.
Yeah, where you got like I1 and then I2 and then I total and then it's like those two.
Oh, like a. Okay.
Okay, so I'm just gonna do the one like the exact problem he has, so that way we can get numbers that will be realistic. So this is gonna be 72 volts. This is going to be 24 ohms.
Second one's 8 ohms.
8 ohms.
Last one's 3 ohms.
Okay, and the bottom one
2 ohms.
2 ohms. And then what's the capacitance on the other ones? Does it even say?
Nope.
Yeah, it doesn't really matter because he's not asking for like specific things on that. So he's asking, what he is asking is the total current out of the battery at t equals 0. So remember, there's 2 different times, t equals 0 and t as t goes to infinity. So at t equals 0, does anybody remember the rule for capacitors? What are capacitors? Like, yeah, straight wire. So C is straight wire. As long as I can spell straight. So C is a straight wire.
So it still goes through that.
Yeah. So basically, yeah. And so in this, as t equals 0, it'll just flow. Yeah.
All 3 act like normal.
Yeah.
Basically
You'll include all 4 of these resistors in the total resistance. But as t goes to infinity, that will not be the case because the C's equal as basically our block. They will not allow charge to go through. So that means, so here you'll do R1, R2, pretty sure this is R1, R2. He didn't even mark it, so it doesn't matter. R3 and R4. Yeah, so the first one you use all of them, and the second one you'll just use 2 of them. So right now, for t equals 0, the total current coming out, we'll have to do all of them in parallel here, 1, 2, and 3. So equivalent of R1, 2, 3, 1 over R1, 2, 3 equals 1 over 24, plus 1 over 8, plus 1 over 3.
2.
2?
Yeah.
Oh, see, it's so nice when they work out. Yeah, okay, so basically you can now think of this once again as like 2 just series resistors, where this is 1 resistor and obviously this is still 1 resistor. So our total equals 2 ohms plus 2 ohms again. So R1, 2, 3 and R4, and obviously that equals 4 ohms. And so then your current coming out of there will just be, once again, V, which is 72 volts, divided by R, which is 4 ohms.
18.
And that equals 18 amps. So everybody, yeah, I mean, everybody understands that, right? The only like difficult part of these ones really is just knowing, is it blocked or is it acting like it's not even there at all? So. So yeah, the total current was in fact 18 amps. The voltage across capacitor C1 as t goes to infinity. So let's see. Actually, let's do this other one that is at t equals 0. So the current through R1 at t equals 0. So the current. To say the current. Well, that's fun. It had to be current. Okay. So so what you have to do first is find the voltage across the top part. So voltage for R1, 2, 3. So all you have to do for that is V for 1, 2, 3 is just going to equal I total 18 times 2 ohms. So V for that is going to equal 36 volts. So that's the voltage across each one. And so to find the current, for that, you'll just be doing I1 equals V1 divided by R1, which equals 36 divided by 24, which equals like 1.5, I'm pretty sure, right?
Yeah.
Yep.
Which equals 1.5 amps. So notice every time that we have something in parallel, we're finding the voltage across all of them, and those are always equal. But the current is not. So we have to find the voltage across all of them to find the current in one of them. So that's kind of the process you're going to have to go to. So find the total current across coming out of the battery, find the voltage across the resistor like of interest, and then use that to find the current across just one resistor for resistors. Okay. So if you want to do, let's say, the current across R3, in this case, you do the exact same thing. You'd find the same voltage is going across R3, but then in this equation you just replace R1 with R3, and so you'd have 36 divided by 3, which is 12. Okay, cool, good stuff. Okay, so the other 2 problems are for t goes to infinity. So we need to change everything. So we know our I total at t goes to infinity. That's one very same thing. So now t goes to infinity, the capacitors act as a block, so you only have 2 resistors, and they're both in series. So this is really easy to find. So our total just equals R2 plus R4, which equals 8 plus 2. So our total equals 10 ohms. So I total just equals 72 volts divided by 10 ohms, which equals 7.2 amps. Okay. I don't think we needed to find the current, did we? No. Okay. So the first one is the voltage across capacitor C1 as t goes to infinity. And did he even give a value for that?
I have no clue how he.
Yeah, I didn't get his work on it either.
Did he even give a value for C?
He did 0.8 times 72, and that's how we're supposed to get the answer.
It's 7.2 times 8.
Yeah, so that's so basically you just have to the voltage across all three of them are still going to be the same. So the voltage across all three branches will still be the same. So you just have to find the equivalent resistance across the three again. But in this case you only have one resistor. So to find that you just have to do the voltage across 1, 2, 3 just equals I total times R1, 2, 3, which is in this case just R2. So this is just R2 because it's the only one that's actually putting in any resistance. Okay, so V123 equals 7.2 times 8, right? Which equals, I don't really. 57.6.
Yeah.
57.6 volts. Okay, so and that's the answer. So the voltage going across this one is the same as the voltage going across this one and this one, but all the voltages across this branch and this branch are being taken up by C1 and C2 respectively. So that means the voltage across this capacitor is 57.6, this capacitor is 57.6, and across this resistor is 57.6. The voltage across the resistors here are 0. Okay, I think that's the next question. Yeah, the current through R1 as t goes to infinity is what? 0. Yeah, so there's no current going through here. This is blocked. So there is, yeah. So originally there'd be I through here, and I through here, and I through here. But since this is here, this is blocked for when t goes to infinity. So all of the current will be going through here, and in that one obviously. So yeah, so the answer to number 10, the current through R1 as t goes to infinity is 0 amps. The current going through this would be the entire current that we found, which was 7.2 amps, because it's basically just in series with the other one, so it'll get the entire current. Okay? That's all of the questions.
Why did he say that?